Hello everyone, I am Ram Prasad, pursuing BG in the stream of ECE at KLN College of Engineering at Sivagangai, Tamil Nadu. Today I am going to demonstrate simulation of washing machine using PIC16F877A that I have learnt and done during my internship at Emertxe Information Technologies. At the end of this internship, I learnt about Introduction to Embedded Systems, Basics of Embedded C, Introduction to Microprocessors and Microcontrollers, and project requirements and its implementation. In Introduction to Embedded Systems, I learnt about basics of embedded systems. So basically, embedded system is a combination of hardware and software designed to perform specific tasks. And also we learned about how to program an IC using embedded C, using which we have done our project. Examples of embedded systems are washing machine, AC, fridge and pacemakers and etc. So basically there are two main types of embedded systems. One is classified based on their performance and functional requirements, and another one is classified based on their performance of microcontroller. Based on functional requirements, it is classified into four types: real-time, networked, mobile and standalone. And based on my performance of microcontroller, it is classified into three types: small scale, medium scale and sophisticated. In the basics of embedded C, we learned the usage of embedded C. The main areas where the embedded C is used are in development of system software, embedded software and OS kernel development. Regarding the characteristics of embedded C, it is a general purpose language and has many library functions, which is very important. The format of embedded C has documentation, preprocessor statement, global declaration, main code and the function body. And we also learned regarding data types and number systems and also conditional constraints like looping, for loop, while loop and do while loop. So these are the blocks of embedded systems. It has sensors, ADC that is analog to digital converters, processors, digital to analog converters that is DAC, and memories and actuators to perform specified tasks. Comparison of microcontroller and microprocessor. The microcontroller are ICs capable of being programmed to perform a single task. It has simple design architecture and all the components are available in a single chip. In contrast, microprocessor ICs are capable of being programmed to perform any task, and comparatively the design architecture is complex than the microcontroller, and peripherals are needed to be interfaced separately. These are the details of PIC16F877A board. The operating frequency of board is 20 MHz and the flash memory is of size 368 bytes. The EEPROM data memory is of size 256 bytes. There are 15 interrupts in the board and the input-output ports are totally 5 in number, which are A, B, C, D and E. There are 3 timers and 2 pulse width modulation modules in the board. It also has various components like CLCD, fan, tactile switches, buzzer, LEDs, ADC and RS-232 for communication. Our goal is to simulate a washing machine using PIC16F877A replicating a real-world washing machine. The microcontroller used here is PIC16F877A. The software used to build this washing machine are MPLAB XIDE, PIC16Lab and XE8 compiler. So about MPLAB XIDE, MPLAB is a proprietary free software which is IDE. IDE is nothing but integrated development environment. It is developed by Microchip Technologies. It is being used for programming and development purposes for embedded systems. The version which we have used for our project is 5.35. Regarding PIC16Lab, it is a proprietary free software for simulation of various microcontroller boards available. It can simulate most of the widely used boards like PIC Genius, Arduino, STM and ESP, etc. This is the block diagram for the requirement. Washing machine should be powered on using switch 5. The washing cycle should be paused or stopped using switch 6. The navigation, that is scrolling between the options and selecting any option, should be done with switch 4. Door status should be controlled with switch 1. That means when the switch 1 is pressed, it denotes that the door is open. The washing status will be displayed on CLCD available in the board. The buzzers are used to indicate the completion or any interrupt in the washing cycle. The motor is used to show the working of washing machine. One of the important components used here to control the washing machine is the tactile switches. This photo represents the tactile switches and its schematic format. These are the switches which will be in on mode only when the switches is pressed. Here the RB3 is used as switch 4, which is used for navigation and scrolling between the options and also to select the options. The RB4 is used as switch 5, which is used for powering on the washing machine and also to resume if the washing cycle is passed. The RB5 is used as switch 6, which is used to stop and pause the ongoing program. RB0 is used as switch 1 to indicate the door status of the washing machine. This is the schematic representation of CLCD display. The CLCD in washing machine is used to display the current status of the machine. It is also used to show the various options and navigate through them using switches. It also shows the time remaining to complete washing cycle. This photo represents the schematic of the timers. Timers in the washing machine is used to keep in track of washing timers. In the normal washing modes, the time is split into three modes: wash, rinse, and spin. The time for each mode is split into a certain interval and the same is displayed in the CLCD. This photo represents the schematic form of the buzzer. The buzzer in washing machine is used to keep in track of washing cycle. The buzzer alarm activates when the door of the washing machine is open, which is represented by clicking RB0. And also activates for 3 seconds when the washing is completed successfully. The fan in the project is used to represent the working of washing machine. Spin of the motor starts when any washing mode is selected and continues till the end of washing cycle. The motor stops when it detects any door is opened and starts again when the door is closed. Now let us see the demonstration. So this is SemptyLab XIDE. Here in the main.c file we have written the coding for the washing machine. So to create a hex file, we should clean and build. Upon the successful completion, we should load the hex file to the PIC16F877A. If the build is successful, then we should open PIC16F877A. I'm going to file and load hex file. We should select the created hex file and open. And when we press key 5, it will power on washing machine. Here it shows options. You can navigate through them using the switch 4, this RB3. To select an option, we should long press the switch 4. Now we are selecting delegates. So here shows the water level. You can navigate to it. So we are selecting medium. So here shows press switch 5 to start, switch 6 to stop. When we press switch 5, it starts timer. So when we press switch 6, it just passes the program. And when we press switch 5, it starts the program. When we press the RB0, that is switch 1, it indicates the door is open and produces the buzzer sound. And when we leave the switch, it resumes. Here it shows the washing mode. Yes. And we get this buzzer sound when the washing is completed. In conclusion, our washing machine simulation using PIC16F877A microcontroller demonstrates not only practical application of embedded systems in household applications, but also showcases the efficiency and versatility of the microcontroller-based designs in real-world scenarios. The ease of programming the microcontroller board can be very handy to create and develop advanced machines using the microcontroller and also play a vital role in development of technology. Thank you.